Welcome to Sundar's lecture. This is lecture number 54. We will solve a dependent sources problem by applying Thevenin's theorem and Norton's theorem. Right? So now before that we try to find what is ZTH with a different procedure. See what is the procedure to find ZTH. See, if you want to find what is the ZTH, then you need to open circuit the load resistance or whatever the resistance connected across point A and point B, and we need to deactivate all the sources in the linear network. If it is voltage source, then you need to short circuit. If it is a current source, then you need to open circuit. We have not seen that anyhow. Then we need to find what is the impedance across these 2 points by simplifying this network. See what is the ZTH we have got here. Anyhow, the circuit we have taken in the both cases are same, right? What is the ZTH we have found? It is 2.4 ohms in this Thevenin's network, in the Thevenin's theorem procedure. Then you see here in Norton's theorem also ZTH is same 2.4 ohms because this is the load resistance, right? So if you open circuit this load resistance and you need to find what is the equivalent resistance across this point. So ZTH in both cases are same, and it will be same in if you are going for any other problems also. Anyhow, the procedure we have followed: open circuit the load resistance and short circuit the current sources, and open circuit the short circuit the voltage sources and open circuit the current sources in the network to find what is the voltage, what is the impedance across these 2 points. This is the procedure. But now see, I will write a different procedure now, right? What is ZTH? ZTH will be is equal to VOC, or we will call it as VTH, right? Open circuit voltage divided by ISC, or we will call it as IN. And if you use this expression, obviously you will get what is ZTH. Right? What is the ZTH for both in both cases? It is 2.4 ohms, right? So we know ZTH, which is equal to 2.4 ohms. We have found this one. But substitute in this equation now. Substitute what is ZTH. See what is VOC we have got in this problem. What is VOC? See where is VOC? This is VOC or VTH. Both are same. 9.6 volt. Right? So it will be 9.6 divided by what is ISC or IN we have got in this problem. See ISC we have got it to be 4 ohms. Right? So if you simplify, if you substitute here it is 4 ohms, then what is ZTH? Obviously ZTH becomes what? 2.4 ohms. So it is not the mandatory thing to get ZTH by doing this one. No, you try to find what is the open circuit voltage and what is the short circuit current across these 2 points A and B. Then you divide those two, you will get what is ZTH. That is also a good procedure. You try it by yourself, you will get an idea. Right? We will take up now a problem, and then we try to solve that problem using Thevenin's theorem and Norton's theorem. See, we have taken a numerical problem with the dependent sources, and what is the problem here? So we need to find what is the current IL in the circuit. See, this is point A and this is point B, and this whole network will be the linear network. Right? This whole network will be now linear network, and we need to find what is the current in this particular branch. See, we will take Thevenin's theorem to solve this problem now. Let us assume that we are going to solve this problem by Thevenin's theorem. See, since there is a dependent sources available, then you need to obviously go by to find the Thevenin's impedance is not, we cannot go by the conventional method by short circuiting, open circuiting the voltage sources. It is not at all possible. Anyhow, see, we will solve this problem by Thevenin's circuit or Thevenin's theorem. See, if you are going to solve the problem by Thevenin's theorem, then what you need to do? You need to draw the equivalent network. See, this is the equivalent circuit now. So this is VTH connected across ZTH and ZL. So ZL is given, right? Here it is 1 ohms, that is given, and we need to find what is VTH as well as what is the ZTH value. We try to find what is now VTH now. So to find VTH, what is the procedure? So now we try to find VTH. So to find VTH, what we need to do? You just open circuit this load resistance and find what is the voltage across these 2 points VAB, right? So I will draw the diagram again. See, I have drawn this diagram. So we have open circuited the load resistance, and we need to find what is the voltage across these 2 points. So if you want to find voltage across these 2 points, then obviously what you need to find what is the current in this branch, or we can follow a different procedure, right? So we need to find what is this V1. If you know what is this V1, then we can start from this point B and go to this point and come here, and we can easily find what is the voltage across these 2 points. For that, also you need what is the value of I1 also. So this is plus and this is minus. That is what given in the question. Now you see what I am going to do. I am just going to write the KVL expression for this loop, this outer loop, right? So this is the current I1, that is also they have already given. So you just write it down. This is I1. See what I am going to do. I am just going to write the KVL expression for this particular loop. So start from this point, go in this way. So if you are going in this way, so I am just writing KVL. So KVL start from this point. So if you are going in this direction, so this will be plus 2, and I am going in the same direction as this current I1. So I have to put minus 3 into I1. Then I have to come in this way here. You see, you don't consider whatever the current or resistance connected here, because we know these 2 points will have voltage V1. So from plus to minus, I am traveling in this voltage. So this will be minus V1. So that's all. So this should be equal to 0. So this is expression number 1. And what I am going to do, I am going to apply KCL at point C. At point C, I am just going to apply KCL. So if I am applying KCL, then what are all the things? So current I1 is coming in. So current, so we need to put equal to symbol. Current I1 is coming in. So it has to be I1. And this current V1 by 6, that is the current source, right? V1 by 6 is going away. So this will be V1 by 6 is going away. See, there is a 6 ohms resistor here, right? There is a 6 ohms resistor here. And what is the voltage across these 2 points? It is V1. So what is the current in this one? In this way. So if you are considering this to be this one, because from plus to minus, the current flow will be there in a resistance. So what is the current flow? Then it has to be V1 by 6, right? The voltage, it is V1. The resistance, it is 6 ohms. So V1 by 6, that is the current flow in this direction. So there will be a current flow in this direction. So it is also going away. So this will be V1 by 6. So if you simplify this one, so I1 will be is equal to 2V1 by 6, and it has to be, this is 3 times and this will be 1 time. So it will be V1 by 3. So the combination of I1 and V1 will be, it will be V1 by 3. So make it as expression number 2. Substitute now 2 in expression number 1. So you just substitute in this I is equal to V1 by 3 in this expression. So what you will get? It will be 2 minus 3 into I1, it is V1 by 3, right? So minus V1, which is equal to 0. And this 3 can be cancelled out. So 2 minus V1 should be is equal to 0. And this will be now, so 2 minus 2V1 that is equal to 0. So what you will get? So you will get 2V1 which is equal to 2. So V1 will be what? V1 will be which is equal to 1 volt. So V1 will be 1 volt. So we know what is now V1, right? So if you know V1, then also what you need to know? You need to know what is I1 to find what is the VAB, right? Then if you want to find what is I1, then what is I1? See, I1 will be is equal to V1 by 3, right? And then what it will be? V1 by 3, then it will be 1 by 3. So in this expression, you just substitute this V1 in this expression. So I1 will be is equal to 1 by 3. That is also we have found. Now try to find what is VAB, and that VAB should be equal to what? VTH. VTH. So start from this point, go in this way. See, I am going from minus to plus in this V1. So it will be plus V1, and here I am just traveling from plus to minus in this voltage source. So I have to put minus 9 into I1. That is the voltage source, right? Minus 9 into I1. So I have reached point E. So that should be VAB and that should be VTH. So VTH will be is equal to V1. What is V1? We have found it is 1 volt minus 9 into what is I1? That is 1 by 3. So this will be 1 times and this will be 3 times. And this is 3 and 1 minus 3 will give you what? So VTH, which is equal to, maybe we will take it write it in a different color. So VTH will be is equal to minus 2 volt. Will be is equal to minus 2 volt. So we have found what is the voltage across this particular point A and B. So now what we need to do, so we know what is VTH and we know what is Z. We have already given it to be 1 ohms, and we need to find what is ZTH. How will you find ZTH? So you need to open circuit this load resistance, and you in this linear network, whatever the sources you are having inside the network, you need to deactivate all of them. So how will you deactivate this? You see, here you are having 9I1 and this dependent sources cannot be deactivated as the independent sources. So what you need to do, you just find what is the short circuit current IN and divide VTH by IN, obviously you will get ZTH. So simple, right? So what you do now, find what is ISC by short circuiting this load resistance. Then you divide VTH and Z as IN, you will get ZTH. Find it, put it here in this expression. That is very simple, right? So we will take this circuit again. And now you see, we have taken the circuit to find what is the short circuit current, right? So in the load side, what you need to do, in the load side, you need to short circuit, and what is the current flowing through that particular short circuited branch, you need to find it as IN or ISC. We know this one, right? So now you see, if you see any circuit with the dependent sources, what you do, you try to find or try to write KVL or KCL expression wherever it is possible, and somewhere else you can easily find the unknown parameters, right? So for example, see, I need to find IN, right? That is my ultimate aim. I need IN. So what I will do, I try to write the KVL expression in this loop. I will write this one. See, so if I write the KVL expression in this loop, what it will be, see, starting from this point, so my current is flowing in this direction, right? IN is flowing in this direction, so I will write like this. So if I am writing like that, so see, from this point I will start, so from minus to plus I am going, so it will be V1. So this will be V1, and V1 from, this is actually plus, from plus to minus I am just going in this voltage source, so that will be minus 9 into I1 should be is equal to what? 0. That's all. This loop voltage equation has been written. So let us consider this to be equation number 1. And now for the second instant, what I am going to do, I am just going to write the KVL expression for this whole loop, for this loop, right? So why I am doing that? Since I will get I1 here. It is very simple, right? So you try to understand, I will do that. So start from this point and I will go here, come in this way, and then you complete the KVL expression for the outer loop. So start from this point, it will be plus 2, and from minus 2 plus I am going. So in this way, the current and the direction I am going are same. So I have to put minus 3 into I1, minus 3 into I1, and then I will go in this direction. So here you see in a voltage source, I am going from plus to minus. So it will be minus 9 into I1, minus 9 into I1. That's all. I have completed the loop, which is equal to 0. See here, what is this one? Both are same. So it will be 2 minus 12 I1 will be is equal to 0. And simply you see, if you bring this to that side, which means this minus 12 to that side, this become plus 12, then I1 will be 2 by 12, and that will be I1 will be is equal to 1 by 6 amperes, 1 by 6 amperes. That's all. So we have found what is I1. If you know what is I1, so make it as expression number 2. If you know what is I1, obviously what you can do, you can find what is the voltage across this branch. Very simple, right? Voltage across this branch can be easily found. And if you substitute 2 in 1, 2 in 1, 2 in 1, what you will get? So V1 minus 9 into, what is this one? You have to substitute 1 by 6 here. So this becomes 1 by 6. That should be is equal to 0. So this will be 2 times and this will be 3 times, right? 3 by 2. So what is V1 now? So V1 should be is equal to V minus 3 by 2. So it will be plus 3 by 2. 3 by 2 volt. So make it as expression number 3. See, I have taken the circuit again to explain uh, deep into this particular circuit, right? So see, now what I need to do, I need to find this IAC. See, I have written this IAC here in this place. Both are same, right? Because this is the completed loop. So maybe the current, whatever the current is IAC here, that will be here, right? So now you see, you apply KCL at point C. So I will write it down. KCL at node C, right? Node C, in node C. See what is the current coming in? It is I1 is coming in, and one current that is going away, that is nothing but it is V1 by 6 is going away. And what should be the current here? I am just considering it to be X, right? I am just considering it to be X, and it is also going away, right? So if it is going away, I have to put it here. So now what is X? X should be is equal to I1 minus V1 by 6, right? We have found what is X, right? What is X? Now what you do? Apply KCL at node D. At node D, what is the current coming in? X, right? X is coming in, and what is the current going away here? That is nothing but V1 by 6, right? We know the voltage across these 2 points is V1, and what is this one? This is 6, so resistance is 6, so the current will flow in this direction, and that is V1 by 6. So it is going away, so that should be is equal to V1 by 6. And what is the current flowing away here? This is also going away from this node. So what is that current? That is nothing but IAC. That's all. That's all. We have written the expression. See, you can substitute X here. So what you will get? I1 minus V1 by 6 will be is equal to V1 by 6 plus IAC. And you need only IAC, right? So if you find what is IAC, I can write it down. IAC should be is equal to I1 minus V1 by 6 minus V1 by 6. And if you further simplify this one, this should be is equal to minus I1 minus 2V1 by 6. And if you cancel this one, this will be 3 times and this will be 1 times. So it will be I1 minus V1 by 3. That should be ISC. That should be ISC. And if you substitute, we know what is V1, right? So we know what is I1 and as well as V1. So you just substitute in this equation. ISC should be is equal to what is V1? It is 3 by 2. What is I1? I1 is 1 by 6 minus what is V1? It is 3 by 2. 3 by 2 divided by 3. And what you will get? 1 by 6 minus 3 divided by, you multiply these two, it will be 6, right? So you will get both are same. So minus, if you minus these two, it will be minus 2 by 6. So this will be 3 times and this will be 1 time. So ISC will be is equal to minus 1 by 3 amperes. Minus 1 by 3 amperes, right? This is the expression we have got for ISC, right? So we have found what is ISC. Now you see what is the question asked here. You need to find what is the IL. But we are solving this problem using Thevenin's theorem, right? So by Thevenin's theorem means this is the formula, and we know what is VTH we have already found, and Z we know that it is 1 ohms, and you need to find what is ZTH. What I have told you, if you want to find what is ZTH, then you need to divide, then you need to take the ratio of VOC and ISC, right? That is what we have got here. ISC we know. Now we try to find what is the value of ZTH. So ZTH will be is equal to VOC by ISC. VOC by ISC. Then what is VOC we have found? VOC or VTH both are same, minus 2, right? So this is minus 2 divided by, and what is the value of ISC? Minus 1 by 3, right? So this will be minus 1 by 3. And if you simplify this one, you will get ZTH will be is equal to 6 ohms. 6 ohms. And if you bring this minus will be cancelled, 3 to the numerator, you will get 6 ohms. Now we have found all the values, right? See, we have found what is ZTH. So you substitute in this expression IL. So IL will be is equal to VTH divided by Z plus ZTH, right? So what is VTH? So what is VTH we have found? It is minus 2 divided by, and what is Z? Z, which is nothing but it is 1 ohms. So this will be 1 ohms. And what is the value of ZTH? That should be 6 ohms. And if you simplify this one, IL will be is equal to minus 2 by 7, right? So then if I find what is IL should be is equal to minus 0.286 amperes. So we have found what is the value of IL now. Try to understand this one. We have found it by Thevenin's theorem. Thevenin's theorem. And if you want to find the same problem, using Norton's theorem, then what you need to do for Norton's theorem? See, I will draw the Norton's equivalent circuit. Norton's equivalent circuit. What is the Norton's equivalent circuit? You know, right? This should be ISC, and there will be a resistance. Connected parallel to this current source, and there will be the load resistance connected parallel to the ZTH. So this value will be ISC, and this is nothing but ZTH, and this is Z. We know this will be 1 ohms, and we need to find what is IL, and we know what is the formula for IL. What is IL? IL will be is equal to ISC into ZTH divided by ZTH plus Z. This is the formula, and we know everything now. We know everything, right? By this method also, we have found what is ISE. What is ISE? It is minus 1 by 3. So it will be minus 1 by 3 into what is ZTH? We have found that this is 6 ohms. So this will be 6 divided by 6 plus 1. This is 1 ohms, right? So if you simplify this, obviously IL should be is equal to minus 0.286 amperes. You will get. You try to simplify this. See, we have taken a single problem, and this one we have got it through Norton's theorem. Norton's theorem. See, we have taken a problem. This is the problem, numerical problem given to us, and you need to find what is the current in this branch. Maybe this is the load resistance, 1 ohms is given to us. Then what we have done, we have started to solve this problem using the Thevenin's theorem, and we have drawn the Thevenin's equivalent circuit, and we have written the IL formula, and we need to find what is VTH and ZTH, and we know the procedure to find what is VTH. Just open circuit this one and find what is the voltage across this branch, and you will get what is VTH, maybe open circuited branch. Then what I have told you, if you want to find ZTH, we would have followed a different procedure in the previous problem. What is that procedure? You need to open circuit this load resistance, and you need to deactivate all the sources in the linear network. Maybe in this network or in this problem, this is the linear network. Across point AB, that will be, we are calling it as linear network. But what I have told you, since there are dependent sources present in this problem, it is not very easy to find the equivalent resistance. So I have followed a different procedure. What I have followed, or what we have followed, we just short circuit this resistance to find what is IN, and I have told you, if you want to find Thevenin's resistance or Thevenin's impedance, just you take the ratio of open circuit voltage and short circuit current. That is what we have done. See, we have found what is ISC by using the, there are so many procedures we would have followed, and we have found what is ISC, and at last ZTH we have found it by taking the ratio of VOC divided by ISC, and this is the ZTH value, and we have found IL value by Thevenin's theorem and also by Norton's theorem. So you try to solve so many problems with the help of this knowledge, and we will take up the new topic in the next class. Thank you.